All right, for example 4 here, I'm gonna work a little bit with VDBs and show you guys kind of a couple of things you can do with them and kind of how that sort of volume works. As I said, it's a very fast and very memory low cost volume to work with, which is really cool. It's very good for exporting to different packages, and yeah, it's overall a really nice representation of volumes. So we're gonna start off by having a sphere here. It's a regular sphere. We're gonna make it into a VDB from polygons with the VDB from polygons node. This will basically just create a VDB from a polygon surface. We're gonna use it. We're gonna make it into a distance VDB. So we're gonna take this box and we're gonna type the field into surface. We're gonna put the voxel size to 0.03, which means our resolution will be 39 by 39 by 39. And a voxel count of 20,968. Then on the other side here, we want to do a little bit different thing. We want to scatter points on the surface, 33 to be exact, and then we're going to make a VDB from particles. The VDB from particles is kind of similar to VDB from polygons. It's just some other little bit different things in it, but it's kind of similar. So the VDB from particles, you can define the point radius. This also works on p-scale. So if you have a p-scale on him, let's type a attribute create and put p-scale, and let's put the p-scale to 5. You can see that they kind of work with each other. So if you have a p-scale, it's gonna automatically detect that and kind of put the radius to that. But yeah, so you can kind of define it here. If you don't have a p-scale, you can do minimum maximum radius here, some other things here, and yeah, you can also make them into density, obviously. But yeah, so I'm gonna keep both of these to distance VDB to surface, and I'm gonna go and do something here called VDB combine. What we can do with this node is we can either combine VDBs or we can like kind of do Boolean operations like this, which is really cool. So what I've done here is I've piped the big sphere into input A, and the little spheres or little particles into into input 2 or B. And in here I've done a SDF difference. I can do a lot of things with operations. I can do a maximum. I can do a minimum, which actually combines them. I can do a, not invert, subtract, which is sort of similar to what I'm doing, but I prefer creating an SDF. I can create SDF intersection, but we want to do an intersection SDF difference, which will give us this kind of sheet looking thing. And then we're gonna do a VDB reshape SDF, which will give us some other cool features here, sort of like dilate, erode, open, close. If you put the dilate, we can kind of expand our surface like this. If we do erode, we're gonna do the exact opposite. We're gonna erode it down like that, which can be a really cool effect if you think about it. Next up, we want to do some VDB smoothing with a VDB smooth node. This works as any other smoothing node really in Houdini. It has the iterations. We can put into 4 here, and the fixed filter voxel radius, put it to 1. Then next up we have a convert VDB, which actually converts our VDB back to whatever we wanted to convert to. We can convert it to a volume, we can convert it to a VDB and change it to be not SDF anymore. We can change it into fog, which makes it into a density field. We can also make it into a polygon. So now we're back at polygon land, which means we no longer have any voxels or any voxel resolution. We only have points, primitives, vertices, and polygons, which is one way of doing things as well, if you want to get back to the original thing you had here. So that's a couple of things you can do with VDBs and a couple of nodes. If you want to take a look at all the VDB options you have, you can tab click and type VDB, and you will find all the VDB operations you can do here. It's quite a lot, but yeah, it's a cool package. So I'll see you guys in the next example. Thank you.